Good morning, sir.
Good morning, Gurveen. How are you doing?
Good yourself?
Good.
Enjoying the walk, eh?
Yeah, it is.
Lovely nature.
Yeah, it is.
Okay, so what I wanted to say was that I have just finished, in the past June, I finished my grade 11 year school. So with that, I've completed math functions. And that means this coming September, I'll be going to grade 12, so advanced functions.
Yeah.
So I need some tips because now I don't have that much schoolwork to do because I'm off. So maybe we would probably be productive.
Yeah, sure.
Continue to be.
Yeah.
So I want to focus a little bit on advanced functions so I don't forget by the time I go.
Sure.
And particularly the first unit is just functions, right?
Right.
So we know the parent functions. With an exception, they expand a little bit more on the absolute value. But my interest goes towards polynomials because I've seen the cool graphs and the way they go exponentially and curvy. But the only thing is that I don't know. I haven't been taught that before. So maybe if we could start there first.
Sure, we can. Actually speaking, advanced function is an excellent course.
Right.
And normally you may need it for calculus.
Yeah, that's true.
So in many schools it is taught as a pre-calculus course.
Of course, yeah.
So it is going to help you in university also.
Right.
That's a good thing. And yes, actually functions is a good place to begin with.
Yeah.
What we can do is we kind of review functions a bit and then I'll introduce you to polynomials. Is that a good idea?
Yeah, I think so.
That sounds okay to you?
Yeah.
Okay, so what we will do is that we'll have our lectures in open area like this.
Okay.
And I'll give you all visual explanations.
Yeah.
So you'll have to assume some things and in space we'll make our figures and curves.
Figures and curves,
Does
okay.
it sound interesting?
It sounds interesting.
Okay, so what I'm going to do is I'm going to use this as my coordinate plane.
Okay.
Where that is going to be my x-axis, right?
Yeah.
And this is going to be my
Y-axis.
So it could be like this, right?
Yeah.
And that's coordinate 1 for me, right?
Right.
1, 2, 3, and 4, right?
Yes.
So we'll work like this. Origin being at this point. Does
Okay.
it sound okay?
It sounds okay to me.
Okay, so to get to polynomials, let's begin with the very simple, the basic function, which is a constant function. Do you
Okay.
remember anything about the constant functions?
Not much.
Okay, say if I say y equals to 5, what
Yeah.
does it mean for you?
Y equals 5.
Yeah.
It would be
Y equals to 5 will be a horizontal line where for all values of x, y value is 5.
5.
So actually it is the horizontal line and many students think it is a vertical line. It is not so.
Yeah.
And y equals to 5 is a function since for each and every value of x we have a unique value that may be 5.
5.
So it is many to one relation.
Right.
Right? It's a very special function, many to one relation. Now if y equals to 5 is a line parallel to x-axis,
Yeah.
in that case, what do you think is the equation of x-axis? For the x-axis, y is 0. So y
Yeah.
equals to 0 represents the x-axis. So this x-axis is also a function and its equation is y equals to 0.
Because and then it's constant.
Is constant.
Okay, that makes
And
sense.
here, the domain is all real numbers, but the range is only 0.
0.
Do you get the point?
Yeah.
X-intercepts. How many x-intercepts do we have for y equals to 0? So this is my y equals to 0, a straight line which is along the x-axis.
You would have infinite.
Perfect. So we
Yeah.
have infinite x-intercepts, right?
Yeah.
And how many y-intercepts do we have?
We only have one.
Perfect. And is it a function?
I'd say so, yeah.
It is,
'Cause
because
it's-
for all values of x, we have a unique value.
Yeah.
It's a many to one relation.
Right.
Perfect. So that's kind of a good introduction to functions. And
Functions.
these are few things which normally in grade 11 we don't pick up.
Pick up.
And this is where we graduate
Have
to,
Yeah.
to the higher level, right?
Yeah.
The advanced functions. Now, coming back to this point, if I tell you to find equation of my y-axis, what should it be? It's
So shouldn't that also be y equals 0?
not y equals to 0, it is x equals to 0. For
Oh, you
all
switch it.
points, x is 0, right?
Right.
Right, you see? But for each value of x being 0, we have different y values.
So that
Is
makes
it a function?
Yes.
No, it is not. One value of 0 is having so many values of y, right? It is one to many. So when you have more than one value for x value, then it is not a function. It is a relation, of course.
Of course.
But it fails the vertical line test.
Test.
All the points are on the
going
vertical
through.
line.
Okay.
That's the beauty of functions. You see,
I recall something like that.
we think it is very simple, but it's kind of tricky.
Yeah.
Right? Do you appreciate it?
I appreciate
That's
it.
a good beginning. So remember that x-axis is y equals to
equals
0.
0.
It's a function. Y-axis is x equals to 0, not a function.
Not a function.
Where we have just one x-intercept, but infinite y-intercepts.
Right.
Right? So what I will do here is, once we have a class in open like this, I'll post some questions for you.
Okay.
Multiple choice questions, so that you can quickly review what we did outside, right?
Yeah.
So learning outside is always good,
Good.
but practicing is very important, right?
Important.
So as far as the polynomials is concerned, we have introduced you to the very first basic function, which is y equals to k. Now let's look into the second function,
Yeah.
which is y equals to x. Let's say straight line, which you say y equals to mx plus b, right?
Yeah.
So it's a straight line going like this, where b is the y-intercept.
Right.
Right.
So that's a linear.
So that's the linear function. Perfect.
Yeah.
And y equals to x squared. Y equals x squared will be a parabola like this,
Yes,
right?
quadratic.
Decreasing like this, vertex at the origin, and then increasing all
Yeah.
the way, going to infinity. So it extends from quadrant 2 to 1.
Yeah.
Perfect. It has perfect symmetry along the y-axis. It is also treated as an
Even
function,
function.
right?
Yes.
So that way, that reminds me, y equals to x will be kind of a odd function, right?
function.
That is symmetric about the
Origin.
So you have introduced to the terms which are very important to understand in functions, which is symmetry of a function,
Yes.
even an odd symmetry of a function. So even symmetry is when the function is symmetric about y-axis,
Yeah.
and odd symmetry is when the function is symmetric about the
Origin.
How about y equals to x cubed, which is a curve like this? This curve is symmetric about the origin. So it is also
Odd function.
odd function. Well, that introduces us to polynomials. So in polynomials, what really begins with is small terms. Each term is kind of a, first term is a constant, for example. The
Right.
second one is the linear term. Then we have a quadratic term. Then we have a cubic term. And we can keep on adding these terms one by one.
Right.
So each term could be represented as a x to the power of n, where a is the coefficient of x and n is the degree. Do you see
Okay.
that? So the sum of this series is a polynomial.
Yeah.
So I could say polynomial is kind of, if I say a 3-degree
Yeah.
polynomial, I could say y equals to a3x cubed
Yeah.
plus a2x squared
Yeah.
plus a1x plus a0, where x is to the power of 0, right?
Yeah.
So it becomes a series. So that is how we could extend this to infinitely long series. So we can say an x to the power of n plus an minus 1 x to the power of n minus 1, so on.
It goes on.
Yeah, till a2x squared plus a1x1 plus x, 0, a0,
A0.
the constant term. Do you
Yeah,
get it?
yeah.
So this is what a polynomial is. It's a
Really?
combination of all these curves together. Now when you combine them, always, these will be curves like this, very smooth, without any
smooth.
corners. So extending from one infinity to other. So that's the greatness. These are all smooth curves. So here, let me just tell you one thing, that this power, the exponent, should always be a whole number.
Whole number.
It cannot be integer. If I say x to the power of minus 1, it becomes 1 over x. It is not a polynomial.
It's not a polynomial.
Right.
Yes.
A is the coefficients should be real numbers, right?
Greater
It
than
could be
0.
square root 2. It should be square root 2, but real numbers.
Okay.
That is to say, I cannot have sine x, cosine x, log x, exponential x
Yeah.
in my equation of a
Equation,
polynomial.
polynomial.
You get the idea of
I do
this?
get the idea.
So I hope you've been introduced to the basic concept of what polynomial equation looks like. And now we'll discuss further about each graph.
Okay.
Does it sound good?
Sounds good.
Okay, let's move on and then we'll discuss about it.
Okay.
So could you summarize me what you learned in this?
So basically what I learned is that we reviewed a little bit on linear function.
Yeah.
We reviewed quadratic.
Yeah.
So the basics, and we talked about the equation where we have y equals 5. We talked about what's the x equation if y is your constant value for all, which did the same for y. And we talked about odd and even function, which I wasn't introduced, but I read somewhere. So that's how I recall. So like a cubic function would be odd function. A quadratic would be an even function,
Perfect.
because symmetric about the y-axis. And then we go on to polynomials,
Right.
where you have, I think, ax to the power of n.
Yeah.
That's the equation, and is always a whole number.
And there could be many terms like
could be many
this.
terms.
And it's not necessary to have all the terms. Some coefficients could be zero.
Zero.
That means that term is missing.
Right.
I think you've got a lot. Let's move on.
Let's move on.
Okay, great. I'm Anil Kumar. Let us now consolidate our learnings about polynomial functions by answering these set of 14 questions. I have 10 multiple choice questions followed by 4 communication and thinking questions. Let me also thank Gurmeen for making a wonderful video with me.
We shot the video in outdoors and tried to understand the concepts of polynomial functions. Now these questions will help us consolidate our ideas, and I hope they will help you all. Feel free to write your comments and share your views on this series which we are developing for grade 12 students, Advanced Functions MHF4U. Question number 1. Which graphs does not represent polynomial functions? So we have 4 graphs for you. You can always pause the video, answer the question. The first one is a cubic polynomial. Then this is a line, so it is a linear polynomial function. Here we have a quadratic polynomial function, but this is a sinusoidal function, right? Which is not a polynomial. So only D is not a polynomial, and therefore option B is the right option. Now let me also explain here, then when we say the first one is cubic, well, it could be any odd degree function. And this one could be any even degree function. It is important to note that x square may look like this, x to the power of 4 may also look like this, right? So that is to be appreciated. Let's move on. Question number 2 here is, which equation does not represent polynomial function? Now here, let me sketch all of them so that it's very clear to you how these functions look. They will help you to consolidate your learnings, which we did in our video earlier. So x cube will look like this. It kind of turns here and then goes up again. So there is no turning point. So that is how a cubic function will look like. Y equals to 0. Y equals to 0 is actually the x-axis. This is y equals to 0. Y equals to x squared. So that is a linear function, linear polynomial. Is that okay? Y equals to x squared is kind of like this. Y equals to x squared. Now here we have x equals to y squared. Now this is something which you should think about. When I write x equals to y squared, we have to isolate y. So if you isolate y, what do we get? We get square root of x, and that too plus and minus, right? So what we get here is y equals to plus or minus square root of x. Now that is x to the power of half, which is not a polynomial. So this is definitely not a polynomial, correct? So that is one of our answers. X equals to y is a straight line, right? X equals to y is a straight line. So we'll just join this line going through this. Now you'll note this point will be 1, 1. Since 1 cube is also 1, 1 square is 1, and 1 is equal to 1. Is it okay? So that is how it will be. Now the function which is not a polynomial is like a square root, positive or negative. It will also go through this point, will be kind of like this. So this is the function x equals to y squared. It is not a function also. It actually fails vertical line test, right? So if I draw a vertical line here, it fails. So it is not a function. It is only a relation, right? Since it fails vertical line test. Right. So one value of x is actually corresponding to more than one value, 2 values, right? Therefore, it is not a function. Do you see that? So x equals to y squared is not a polynomial function at all. Okay, question number 3. Which equation does not represent polynomial function? Now here, you may have to rearrange your equations. When I say x over y equals to 1, it really means that y is never equal to 0 because it is in the denominator. You cannot divide by 0. But you could write this as y not equal to 0, but x equals to y, or y equals to x, right? So that becomes your function, and it is a polynomial, it is a straight line. Now when I say y is not equal to 0, but y equals to x, that means it is a straight line kind of like this with a hole here, right? So that point is not defined and it goes kind of like this. So this is what it is, right? So it could be a polynomial function with some restrictions, and the restriction is that y is not equal to 0. Now here we have another example, which is xy equals to 1. This we can write as y equals to 1 over x. Now since x comes in the denominator, the exponent will be -1. So this definitely cannot be a polynomial, right? So which equation does not represent a polynomial? Equation B does not represent a polynomial, right? If we look into option C, we get square root of y equals to x. Now you will realize that when we write square root of y equals to x, that really means that x is always positive, right? So x is always greater than equal to 0. Since square root is positive, so when you square it, you get y equals to x squared, but you have to put this condition that x has to be greater than equal to 0. So this function is a polynomial where there is a restriction, and that restriction is that x should be equal to 0. So it's this part of the parabola, right? So this part of the parabola is the function, polynomial function, right? So sometimes you may have situations where part of polynomial is shown in the equation, right? Now the last two are straight lines, right? X plus y equals to 1, that means both x and y intercepts are 1, and that could be the line x plus y equals to 1, where this is 1 and that is also 1. Now if we have x minus y, in that case the x-intercept is 1 but y-intercept is -1. So this line here is E, right? But straight lines are polynomials of degree 1. So these are polynomials. Remember, straight lines are polynomial functions. Right? Only line which is not a function is a vertical line. So remember, note, let me write down a note here. Vertical line is not a function. And what is the equation of vertical line? Equation of vertical line will be x equals to, let's say, a, right? Some value. So those are vertical lines which are not polynomials and not functions. But all of the lines are polynomial functions, okay? Question number 4. Which of the following statements is true? Now we're talking about equation of x-axis. So let me show you what is x-axis. So when I say equation of x-axis, we are saying this is x-axis, correct? Now here y value is 0. Perfect? So this is x-axis and that is y-axis. So along this point, y equals to 0. So now let's look into the options. Which of the following statements is true? Equation of x-axis is y equals to 0. That is correct. And it is a function. Yes, it is a function. Correct? For each x value, we have one value of y, which is 0. So that is definitely correct. Let's look into the other options. Equation of x-axis is x equals to 0. No, this is vertical axis, right? It is vertical, rather y-axis. So that is incorrect. Equation of x-axis is y equals to 0 and it is not a function. It is a function. Equation of x-axis is x equals to 0. That is not correct. So option A is the correct option, right? So I hope all these points are absolutely clear. Question number 5. Which of the following statements is true? Now we are talking about equation of y-axis, right? So what is equation of y-axis? As we saw, equation of y-axis is x equals to 0, and it is a vertical line, right? So we know it is not a function. Is it okay? It fails the vertical line test. So equation of y-axis is y equals to 0. That's not true. Equation of y-axis is x equals to 0 and it is a function. No. Equation of y-axis is x equals to 0 and it is not a function. So option D is the correct option. Now these are very important questions. Go through them carefully since we see them in most of the tests. Question number 6. Which of the following statements is false, right? Remember, is false. Y equals to 5 is an even function. Okay, so let's try to understand what is even function. So when I say even function, we mean two things. One, f of minus x is equals to f of x. Second, it is symmetric about y-axis, right? Two things. So if you draw a graph, you could check symmetry, right? But if you have algebraic equation, you could also check with f of minus x, right? Since it is just 5, it is always 5. So that is even function. Perfect. Let's draw it. Now here, see here. So as you can see, there is a point on either side which is kind of a mirror image. So it is an even function. So this statement is true. Y equals to x minus 1 square is an even function. Now if I have x minus 1, that means the parabola has moved 1 unit to the right, right? So it's kind of like this. Now it is no more symmetric about the y-axis. So this function is not an even function. This statement is false. Perfect. The other statements are true, but let's look into them. Y equals to 2x cubed is an odd function. That's true. X cubed looks like this, and that is an odd function since it is symmetric about origin. We have always a point, mirror image, looking at the origin. Y equals to 5 is a polynomial. Yes, it is a polynomial. Horizontal line is a polynomial. Y equals to x to the power of minus 1 is not a polynomial. That's also true. So the whole idea is to consolidate on our learnings and understanding of polynomial functions, and these examples will help you to do so. So let's look into question number 7 now. Question 7. Which of the following functions is always increasing? Now we'll also sketch them and then try to answer this question. Well, let's understand what is the meaning of always increasing. We should always see the graph from left to right. Right. So always increasing means if there are 2 points A and B, then f of B is greater than f of A if B is greater than A, right? So that is the condition, always increasing. Right. So the very first question is y equals to 7. Which of the following functions is always increasing? Now y equals to 7 is constant. It is never increasing, right? So this is y equals to 7. So that is not the function. Now the second one here is y equals to x squared. Now y equals to x squared decreases. Do you see that? So this is x squared. So it decreases and then increases. So that's not the result we are looking for, right? Y equals to x cubed. Now look here. It is going from minus infinity to 0 to plus infinity. So this is the function which is always increasing. So when you see from left side to right side, you can see that it always increases. Perfect. So that is what we mean. So I hope the concept is clear. Y equals to x to the power of 4 will look like parabola, but it will be like kind of steeper and broader here. So that is how it will look like. All the above except 7. So option C is the right option. That is the only function which is always increasing out of those given here. Question number 8. Arrange the 5 given relations in increasing number of x-intercepts. So we have to find x-intercepts and then we will arrange them in increasing order. Now when I say a constant function ax equals to 0, what does that mean? Now ax equals to 0 basically is x-axis. Now how many x-intercepts will that have? It will have infinite x-intercepts. Bx equals to 6x times x squared minus 1 is 0, x-intercepts means zeros, at x equals to 0 and x equals to plus minus 1. So there are 3 places which are 0 and plus minus 1. Cx is 3 equals to x squared. Now this will be 0 for 2 values of x, and these 2 values are x equals to plus minus square root of 3. The last one here is 0 only for one value of x, that is x equals to 0. So now you can easily arrange them in increasing order. So least is dx, right? And then it is cx. And then it is b. And then it is a, right? So that is the result and it matches with option E. Perfect. So that is how you're going to answer it. Question number 9. So we know a lot about polynomials and here is how we represent a polynomial function. A polynomial function is of the form, let me write here f of x equals to an x to the power of n plus an minus 1 x to the power of n minus 1 and so on, right? Where, as you know, a belongs to, let's say, all these coefficients belongs to real numbers and n is a whole number, right? So n belongs to whole numbers, or we say positive, non-negative, right? We can say non-negative integers. Right, so you can say whole numbers or non-negative integers. Perfect. So that is an example. Now we need to find degree and leading coefficient. Now degree is the highest power. Perfect. And leading coefficient is the coefficient of that term. Right. So these are different terms. Perfect. Normally you will be writing with highest power first. But in test papers this could be mixed up as shown here. Right. So that is the given function. Now what is the degree? Now to find the degree, you have to just check the number on the exponent. The highest is x to the power of 7, right? So x to the power of 7. So the degree is 7 and coefficient is 1. So leading coefficient 1 and degree 7, option D is the right answer. Okay? Do not write 6 and 5. Question number 10. Write degree and leading coefficient of the polynomial y equals to 2x times x squared plus 1 to the power of 3 times 1 minus x cubed. Now we are given 5 options. I would like you to pause the video, answer this question and then look into my suggestions. Now many of you could do mistake here. Remember 1 minus x cubed, now that is kind of tricky. Let me rewrite this function to make things very clear. So we have 2x, x squared plus 1 whole cube. I could write this as x minus 1 with negative power, right? Think like this. Negative power of x minus 1 whole cube. Now this negative power makes it negative. So basically, if you kind of simplify this, you get minus 2x x squared plus 1 whole cube times x minus 1 whole cube. The alternate method could be just multiply all these x's, right? You get a negative x here. So the leading coefficient is negative 2. So negative 2 is the leading coefficient. That's one part. Now the second part is about the degree. What is the degree? Degree is 3 times. Now here we have x squared plus 1 to the power of 3. Now these exponents, you'll have to apply the power rule. They get multiplied. So it will be 6. Now here we have power of 3 and 1. So 6 plus 4 is 10, right? So we have x to the power of 1 here, plus this is 2 times 3. 2 times 3 plus 3. So that is the result. So it is 1 plus 6 plus 3, which is 10. So that is the option C for us. Degree is 10, leading coefficient is, option D for us. Degree is 10 and leading coefficient of -2. Perfect. So that is the right answer. It's a very tricky question. Take care while solving such questions. Now we'll get into slightly descriptive questions. Question number 11. Even function is symmetric about y-axis, right? And f of minus x equals to f of x. Odd function is symmetric about origin, and f of minus x equals to negative f of x. Now the question for you is the function, let me rewrite, f of x equals to x times x squared minus 1, even, odd, or neither, right? So a function could be even, it could be odd, it could be neither. So how will you figure it out? You just find f of negative x. That means replace x with negative x. So we get negative x for first factor. Here if I write negative x whole square minus 1, what do I get? I get, that becomes negative, and this is x times minus x whole square is positive, right? So we get minus of x times x square minus 1, or minus of f of x. Do you see that? So it is minus of f of x. Now clearly, since f of minus x is minus of f of x, this is an odd function, right? So this is an odd function. So if you sketch this function, we'll learn later how to sketch such functions. But if you sketch or see the graph of this function, it has a 0 here in the center, and there are 2 zeros. So this could be written as x times x plus 1 times x minus 1. So add plus 1 and minus 1. These are two linear zeros, right? So the graph will look like this. You see it is symmetric about the origin. So that is how you could solve such a question. Question number 12. I would like you to pause the video, try to understand this question, solve, and then look into my solution. Question number 12 is, graph of an odd function is symmetric about origin. Algebraically, we can show that f of minus x equals to minus of f of x for an odd function. Now the question is the function f of x equals to x cubed plus x minus 1 odd function? Explain. So we are given the function f of x equals to x cubed plus x minus 1. Let's find out what is f of minus x. Replace x with minus x, right? That's the whole idea. Plus minus x minus 1. Now that gives you minus of x cubed minus of x minus 1. Now if I take minus common, I get x squared plus x plus 1, not minus 1. So this is not equal to minus of f of x. Perfect. So it is not odd. You'll find that this is not even either. So it's not even. So this function is neither odd nor even. Well, if you notice, we have odd terms, which are these, and this is even. So this is even, and these two terms are odd. So when you add or subtract odd and even terms, it becomes neither. That's very important to understand, okay? So by inspection also, you could answer if it is a multiple choice question. Question number 13 here, this is the last question. I thought we'll see how to sketch some of the simple polynomial functions, right? So we have 3 of them. The question is, write domain and range of the following functions. Now I'll sketch them and then we will write domain and range of these functions, correct? I'd like you to pause the video, answer and then look into my suggestions. Now when I say y equals to 1 minus x squared, it means it's a parabola opening downwards. At x equals to 0, the value is 1, so it will look like this, right? Where this value is 1 for us, right? Now the second one here is a cubic function which looks like this. The third one is a constant function, y equals to 1, where this point is at 1, right? Now you have the graphs. I'd like you to write down domain and range for these three polynomial functions. So for the first one, the domain is, we could write like x belongs to real numbers, right? So there is no restriction at all. In fact, for all these three, the domain is x belongs to real numbers. So in polynomials, you will notice domain is x belongs to real numbers. Does it make sense to you? Right? So along the x-axis, we have no restriction. However, as far as the range is concerned, it could be restricted. So here, in the first case, we say range, the y values, y belongs to real numbers, but that is the condition, but y is less than equal to 1, right? So the maximum value is 1. So here, this will have absolute maximum. At x equals to 0, right? And the value is 1. In this case, y is going from negative infinity to positive infinity, and therefore the range is all real numbers, right? However, in the last case, the range is only 1, so it is just one value, 1. All x values are mapped with one value, y. Perfect. So that is still a function, and it's a very special polynomial. So linear functions are the ones which do not have those smooth curves, they're straight lines. And remember, vertical line is not a function and it's not a polynomial. Perfect. So with this, we summarize polynomial functions, as you understand, could be written as combination of terms which are constant, linear, quadratic, cubic, and higher powers of x. Now x to the power of should be a whole number, never an integer. As far as the leading coefficient and other coefficients are concerned, they should be real numbers, not sine, cosine, log, or exponential. We also notice that all the polynomials are smooth curves except linear or constant functions. Perfect. With this, let's wind up 1.1 polynomial functions, and now we will try to understand the end behavior and then sketch polynomial functions. Hope you find this series very interesting and useful. Feel free to write your comments and share your views. And if you feel like, you can always subscribe to my videos and learn more about polynomial functions. Thank you and all the best.